Alright, this is some more video on solving triangles that are not right triangles. So, you at this point should have watched the two videos on using law of sines. There's another thing called law of cosines, which is on the help sheet. And law of cosines, I like to say, is a Pythagorean theorem with a little bit of adjustment. Because basically it goes c squared is equal to a squared plus b squared minus 2ab cosine of c. Now the c is not only thought of as the hypotenuse, but we don't have a hypotenuse in this because it's not a right triangle. So the a, c, b are interchangeable. You could also do a squared is equal to c squared plus b squared minus 2cb cosine a. So notice the thing you have to remember is whenever you're using the law of cosines, the side and the angle opposite go here. So notice it's side C, angle opposite C. And then the other two sides, notice that that's side C and side B, and that's the same side C and side B. And that's side A and side A, and that's the same side A and B. So the blue is always the same. The blue are always the same as each other. And the greens are always the same, or as in opposite sides and angles. So law of cosines can be used when law of sines can't. Because remember the condition for law of sines, you have to have a side and the angle opposite it. So like for example, this one, I'm given that I have side A, so I'm going to draw some triangle. I'm not worried about what it looks like so much. I'm going to draw A there, which means this would be capital A, and that's equal to 5. And then we can put B here, which is 7, which means that's capital B. So that means capital C has to be over here, 25 degrees. And so you notice in this case, you don't have a side and the angle opposite it. And you only have one angle, so you can't find any more angles. So we have this side, but no angle opposite it. We have this side, we don't know the angle opposite it. And we have this angle, we don't know the side opposite that. So we can't use law of sines. So we're going to have to use law of cosines. So the only angle we have is 25 degrees. So that means we're going to use c squared is equal to a squared, which would be 25, plus b squared, which would be 49. And that's minus 2 times 5 times 7 times cosine of c, angle c, which would be 25 degrees. Okay? So then we do some simplifying. C squared is equal to C25 plus 49. That'd be 74 minus 2 times 35, which would be 70 cosine 25. Now this is, be careful here. A lot of people are tempted to go 74 minus 70 and get 4, which of course is not true because this is 70 times cosine 25. So you have to do the cosine the 70 times before you do the 74 minus. So let me grab a calculator real quick. Okay, so we solve this for C. We get C is equal to, I just threw all this in my calculator and square rooted it, and I got 3.25-ish. Okay, so that means that C is 3.25. Now, yep. Now, if we're trying to solve this triangle, of course, we need to find some missing angles. I would not use, you can use law of cosines again, but it's at this point, now we have a side and the angle opposite, so we could use law of cosine, or law of sines. So then we'd say, for example, sine of A over A, which would be 5, is equal to sine of 25 over 3.25. Now, when you're solving for angles, you never want to use law of sines to solve for the biggest angle, because if the biggest angle happens to be obtuse, which is bigger than 90 degrees, law of sines will give you the wrong answer. So it's always better to save the biggest angle for last and just solve it by subtracting it from the other two from 180. So notice I went, and the way you know which angle is the biggest is it's opposite the longest side. So we know that B is going to be the biggest angle. So that means I'm going to find angle A first, and then when I get angle A, I'm going to subtract 25 and angle A from 180, and that'll give me B, and I won't have to use law of sines or cosines. Okay, so let's finish this baby. So we got sine of A is equal to 5 times sine of 25 divided by 3.25. Throw all that into my calculator, and I get 5 sine 25 divided by 3.25, and I get sine of alpha of A is equal to 0.6501819, etc., etc. So then I'm going to take the arc sine of that, second answer, and I get A is approximately equal to 40.6 degrees. So then I'm going to do 180 minus 40.6 minus 25, and I get angle B is approximately equal to 114.4. Now, just so you can see what happens if we would have done this, remember I said find the last angle by subtracting 180 instead of your law of sines. Let's show you what happens when I do law of sines. Let's do law of sines for B, and that means we have, what, 7 there? And that would be equal to sine of 25 over 3.25. So if we solve that, we go sine of B is equal to sine of 7 sine of 25 over 3.25. So that would be 7 times sine of 25 divided by 3.25. We get 0.91. Take the second sine of that, inverse sine, and we get B is approximately equal to 65 degrees. Notice that's very different than what we got, isn't it? But if we think about the unit circle, it makes sense, because if you look at the unit circle, the one answer that arc sine gives me is going to be in this angle always, because it's always between negative pi over 2 and pi over 2, or negative 90 degrees and 90 degrees. So it gives me this answer, but what we actually wanted was an answer in the second quadrant, 114. But notice that if this is 65.5 and that was 65.5 because the reference angle, then this angle right here, notice, would be 114.4. So it's the other angle that goes with this one, just because remember, arc sine only gives us one answer. It doesn't give us all the possible answers. In this case, we wanted that one instead of that one. Okay, and so that's why I say, again, you can avoid all that by just always find the biggest angle last and find it by subtracting the other two from 180. Okay, let's do another example. Let's say that I have small a is 4 and big B, or small b is 2, and no, let's do this. Big B, like I said. Big B is 24 degrees, and big A is 47 degrees. So first thing I'm going to do is draw a triangle, and then assess what we want to use. So if we draw a triangle, we get, I'll just draw a random triangle, not worried really what it looks like. Say, let's call this 4, which would make this 47, because capital A has to be across from small a. I said 47, but I wrote 45. 47. And then it doesn't really matter. I'll pick that to be B, which means that's 24 degrees, which means that's small b, which means that's capital C, and that's small c. So you notice in this case, we do have an angle opposite a side. So we can use law of sines. And it's not the ambiguous case, which you learned about in the earlier video, because it's not angle side side or side side angle. I mean, it's not angle side side or side side angle. Yeah, I did say that. Okay. So we're going to do, let's find b first. So I'm going to put 4 on top. I'm going to say 4 over sine of 47 degrees is equal to b over sine of 24 degrees, which means 4 sine 24 over sine of 47 is equal to b. So we'll take 4 times sine of 24, make sure you're in degree mode, divided by sine of 47. And we get 2.2 is approximately equal to b. So now that's 2.22. So, and we also know that 24 plus 47 is 71. Subtract that from 180 and we get 109. So we know that capital C is 109 degrees. And so then all we have left is to find small c. So we'll go small c over sine of 109. That has to be equal to, and always use the one that was given to you, so that would be 4 over, if you can help it at all. And so then we get c is actually equal to 4 times sine of 109 divided by sine of 47. We go 4 times sine of 109 divided by sine of 47. And I come up with c is approximately equal to 5.17. And then we've solved our triangle, found the 3 missing pieces. We found side B, angle C, and side C. Okay, I'm going to do one more example. Let's say that we have A is 4, B is 7, and C is 10. Okay, so it's going to look something like that, where we'll call that 4, that 7, and that 10. That means this would have to be capital C, this would have to be capital A, and that would have to be capital B. So again, we can't use law of sines because we don't have an angle on the side opposite it. So we're going to have to use law of cosines. So I'm going to pick an angle that I want to find first. Maybe I'll find A first. So that means that small a squared is equal to 16 plus 49 minus 2 times, whoops, that's not right. What am I doing here? Small a, nope. That would be 100 plus 49 minus 2 times 70, which would be 140, cosine of capital A. So the 100 came from 10 squared, 49 came from 7 squared, and 140 came from 2 times 10 and times 7. Law of cosines. So, and A, of course, is going to be 4. So that's where my 16 would go. Okay, so we got 16 is equal to 149 minus 140 times cosine of A. Again, don't subtract the 140 from 149 because that's the 140 is attached to the cosine. So first thing I'm going to do is subtract 149 from both sides. So that would be 16 minus 149. That would be negative 133. Negative 140 cosine A. So divide both sides by negative 140, so that'd be 133 divided by 140. And we get 0.95 is equal to cosine A. And we take inverse cosine. Second cosine of my answer. And I get A is approximately equal to 18.2 degrees. Okay, so we go back to the triangle. We know that this is A is 18.2. That makes sense that A is pretty small because 4 is quite a bit smaller than the other sides. Now that we have an angle, of course, we can use law of sines. Don't have to go back to cosine again. So I would say sine of 18.2 over 4 is equal to, and I'm going to find first because C is clearly the largest angle. So I'm going to do sine of B over 7. So that means that 7 times sine of 18.2 over 4 is equal to sine of B. So we got 7 times sine of 18.2 divided by 4.5465, and then I'm going to take the arc sine of that, arc sine, and I get 33.1 degrees. That's approximately equal to B. So that would make this 33.1 degrees. And you don't need law of sines or cosines to find angle C. So I'm going to just take 180 minus 33.1 minus 18.2, and I get that angle C is approximately equal to 128.7 degrees. Okay, so there's a mixed look at different finding the angles, or solving triangles using either law of sines or law of cosines. I generally use law of sines as much as possible. When I can't use law of sines, then I turn to law of cosines. And there you have it.